Good evening to all of you. Welcome to our class today. And the last time we met, okay, we were discussing on how do we get the risk and return. Okay, we were discussing the different methods, okay, that you can use in assessing the amount of return that as an investor you can receive, as well as the amount of risk that that return shall come with. Okay, and we discussed a number of methods, okay, that you can use when it comes to determining the risk and the return. Okay, we mentioned, okay, the use of the variance analysis, okay, as one of the method you can use, as one of the measures, okay, that you can use in assessing the risk of the asset return. Okay, we went ahead and discussed. Okay, we went ahead and discussed also. Okay, the use of the standard deviation. Okay, the use of standard deviation as a measure of risk. Okay, and we see that essentially standard deviation is simply the square root of the variance. Okay, standard deviation is simply the square root of the variance. Okay. Don't forget, the higher the value, okay, the more the risk that you have, okay. The higher the value you have for variance, the higher the value you'll be having for the standard deviation, the higher the risk of the return that we shall be receiving from that particular asset. Okay. We had discussed also on the use of the covariance, okay, the use of the covariance. And covariance, essentially, it is simply how do the return of two assets, okay, move together. Okay, how do the return of two assets move together? How do they vary, okay, together? Okay, if one asset return is decreasing, what is happening to the other asset return? Okay, if, for example, we get a positive value, okay, we see that simply it means therefore that in case one asset risk, if it simply means therefore if the return of asset A is increasing, okay, then of course a return of asset B is increasing. Why? Because they simply have a positive covariance with each other. Okay, if the covariance of the two assets, okay, A and B, okay, is negative, then what does it mean? It simply means therefore if the return of A is increasing, okay, the return of B is decreasing. They move in opposite direction. Okay, that's why we have a negative covariance. Okay. We also did discuss, okay, the use of the coefficient of correlation, okay, the coefficient correlation, okay, and we see that one of the key disadvantage of the use of the covariance is that we don't know to, okay, yes, the positive figure, okay, is a negative figure, okay, but to what extent is that increase or decrease, okay, to what extent is the increase or the decrease, okay, if one is increasing, okay, if the covariance was a positive, okay, then we simply mean therefore that if the return of asset A is increasing, then for B is increasing, but by how much? Okay, that is what we don't have under the use of the covariance. Okay, that's why we say it was enough that we do have called the coefficient of correlation. Okay, now this again put a scale, okay, between +1 and -1. We see the case, for example, we do have +1, okay, as the correlation between the movement of return of asset A and asset B, okay, then what does it mean? It means that for if a return of asset A are increasing by 10%, the return of B are also increasing by the exact same amount, by the exact same value, 10%, okay? There is called the perfect, okay, positive correlation. Okay, if it is negative, okay, we went ahead and said if the correlation is negative, then simply if the return of A is increasing, the return of B is decreasing. If A is increasing by 10%, then B is decreasing by 10% also. Okay, I think we did discuss all these. Okay, last time we met. Okay. We discussed we can also use what we call the coefficient of variation. Okay, the use of coefficient of variation. Okay. And the coefficient of variation, what is it? Okay, we're trying to determine, okay, for every return I will be getting, okay, maybe 1% of return, or maybe 1 shilling, okay, whatever it is, okay, for every 1 unit of return I'll be getting, how much risk will I be exposing myself to? Okay, how much risk will I be exposed myself to? Okay, that's what was the coefficient of variation, the amount of risk that comes with every unit of return we shall be receiving. Okay. If, for example, the coefficient of variation, okay, is, let's say, for example, 2, okay, then what does 2 mean? Okay, simply 2 mean, therefore, if we are to receive 1% return, okay, from this particular stock, then the amount of risk that comes with that particular return is 2% standard deviation. Okay, it is 2% standard deviation. Okay, so sigma is the total risk for every return received from that particular stock, from that particular investment. Okay, and instead of still giving us the total risk, okay, standard deviation, we divide by the mean return. We divide by the return that was expected to be received from that particular stock. Okay, there was risk, we divide by the return. Okay, that is how we do measure. Those are some of the measures that we discussed regarding how we assess the risk of a stock or a security. Okay, we went ahead and did an example. I think this was example that we discussed together. Okay, this was from the November 2019 question 3B. Okay, today I want us to discuss another example. Okay, to apply all these concepts. Okay, so as we discuss another example, we apply all these concepts. Okay, that we were discussing last time. Okay, so they can stick. So the question is, okay, in your question bank in November 2018, in the November 2018 question 5C. November 2018 question 5C. Okay. We go to the November 2018 question 5C. Okay, so go through it. We discussed together November 2018 question 5 part C. Okay, I hope you go through the question. So this question, okay, you'll be given two securities. Okay, we have A and we have B. Okay, and you'll be given, look, this is from probability distribution. Okay, we have some sort of data. Okay, return from A can be 12, can be 15, can be 10. From B, they can be 6, can be 10.5, and they can be 5. Okay, and the state of the economy, they can be stable. It can either be it is expanding, or else it can either be in recession. Okay, so all these are potential returns that can be received. Okay, the chance of getting stable economy is 0.3, expansionary economy 0.4, and in case the economy is going to be in recession is 0.3. Okay, and of course return dependent on what the economic status of the how the economy will be like. Okay. So the exam is asking you, okay, you get the return from each of the security, you get the risk of each security, you get the correlation of the return of the two securities, and you get the return of the two portfolio in case you invest 60% in A and 40% in B, and 5, you get the risk of the portfolio. Okay. Okay, let's attempt it together. Now, for A, can simply get here, just remember, okay, I'll get here. Recall that we say that the return expected, okay, for a security will be equal to the probability, okay, probability, the sum of probability, okay, just begin from there, okay, the sum of probability, okay, multiplied by the return, okay, from the first set of data all the way to the nth data set, okay. For A, the return, okay, for A will be equal to, you can get 12% return, okay. However, the chance of getting 12% is 0.3, okay. You told that you can also get 15%, okay. The chance to get 15% is going to be 0.4, okay. And you can also get 10%, but the chance you're going to get the 10% is equal to 0.3. Okay, and that will give therefore the return expected from security A. Okay, that's for A. Okay, for B, the same process. Okay, but let's first guess for A. Okay, therefore, what's the return expected for A? The return expected for A. What do you get? Okay, we get 12.6% to the return expected from A. Okay, the same process you're going to apply if you want to determine the return that is expected for B. Okay, for B, okay, you can get 6%. Okay, the chance is 0.3. We told us can also get 7.5% chance bn equal to 0.4. You can also get 5%, and the chance being 0.3. Now, what therefore give us therefore the return expected for B? From a Bontane we get 6.3%. Confirm. From we get 6.3% to be the return expected from security B. Press it forward. That's how we determine therefore the return that we anticipate to get from A and from B. Don't get here. You don't divide by n minus 1. Why? Because this is from the data set is from probabilities. It is probability distribution. So this is not a sample. This is not, for example, a population. So that's why you don't divide by n or n by n minus 1. So don't divide by 3 or by 2. So this is from probability distribution. That's for Roman 1. Roman 2, you're meant to get the risk for each the security. You're meant to get the risk for each of the security. Remember, we said that in case you want to tell standard deviation, the standard deviation, standard deviation, then the risk will be equal to, the square root, of the sum of probability, multiplied by the return received, minus the mean return, squared from the first data set, all the way to the nth data set, from the first data set all the way to the nth data set. That's what we said is how we can determine the standard deviation of the security. So we can apply the formula into A and in B. Let me begin with A. In A, you'll be told that you can get 12. So let's say this is gain P, probability R by R squared. This will be the first probability, 0.3. The outcome then, is 12 minus the mean, which you've just obtained, which is 12.6%. 12.6. Squared. The first outcome, second outcome, the chance is equal to 0.4. The outcome for A then is 15 minus the mean, 12.6. Squared. Then we do the same for the third outcome, 0.3. The outcome then is 10 minus the mean, 12.6 percent. So you get the sum total. Well, the sum total for A. And we get to be 4.4, I presuppose. Yes, we get the sum to be equal to 4.44. And that's given for the sum of the deviations multiplied by the individual probabilities. But the question is asking us to get the standard deviation. Therefore, standard deviation, is the square root of the variance that we've just obtained. Because what we've obtained above there is the variance, which will be equal to the square root of 4.44. And you get how much will be the risk, therefore, of A. The risk of A, they would be equal to 2.11, more or less, 2.11%. 2.11%, therefore, to be the risk of A. We apply the same process, now to B, stock B. Same process, apply therefore to stock B. Probability multiplied by deviation squared. So we do for the first outcome, 0.3. The outcome there is 6 minus the mean. The mean we got was 6.3%. 6.3%. 0.4 is the chance. The outcome then is 7.5 minus the mean, 6.3 squared. Then that outcome is 5, and the chance of it occurring is 0.3. So minus the mean, 6.3 squared. The sum of deviations, squared multiplied by their own individual probabilities is how much? Okay, and from Kami we get the variance to be equal to, or the sum to be equal to 1.11. 1.11. Standard deviation therefore is how much? 1 point, the square root of 1.11 to give us how much? Standard deviation 1.05. They have standard deviation to be equal to 1.05%. Okay, 1.05%. Okay. And that's how we therefore get therefore the standard deviation. Okay, that's what we get therefore the standard deviation for A and for security B. Okay, hope it's all clear. Maybe from there, I think you can now be able to see that A is going to be, it's more risky, okay, compared to B. Okay, as you can see, A has 2.11%, okay, standard deviation. Then for B, it is 1.05 standard deviation, 1.05% standard deviation. So which means therefore B is less risky. However, don't forget the return received from A is higher than the return that is being received. Okay, the return from A is higher than what is being received from B. Okay, so of course the higher the return seems here, the higher is the risk that you as the investor shall have to assume. Anyway, so for now you don't have a clear-cut decision which of the two securities you ought to be picking up. Okay, you ought to be investing in. That is for A. That is for Roman 2. Roman 3, you mean as to get the correlation coefficient between the two stock. Okay, the coefficient of correlation between the two stock. Okay. Don't forget, we need to get the covariance. Okay, before you get the correlation coefficient, you ought to get the covariance. Okay, so that's therefore become therefore our next working. Okay, to get the covariance between A and B. Okay, so covariance. Okay, between asset A and asset B. Okay, and here don't forget the other outcomes. Okay, the first outcome, the chance of it occurring is equal to 0.3. Okay, the deviation for the first outcome of asset A, deviation, is 12 minus the mean. The mean was how much? The mean was 12.6. Okay, 12.6. We multiply by deviation for B. And let me just remind you the formula. Okay, maybe for those who did forget the formula. Okay, of the covariance. We get the covariance between A and B, or I and J. Of course, is the sum of deviation. Okay, probability. Deviation from asset A, okay, minus the mean, we multiply by deviation from asset B, okay, deviation from asset A, from the first outcome, from the first set of data all the way to the nth set of data. That's what we obtain covariance between two securities, okay, and let's apply the formula. Okay, the first outcome for A is 12, okay, minus the mean, 12.6, we multiply by deviation from asset B, which is 6 minus the outcome minus the mean, which is 6.3, I guess. Yeah, 6.3. Okay, 6.3. The chance of this occurring is equal to 0.3. So multiply by probability. Okay, that is the first data set. Second, okay, the economy can be expansionary. The chance of it occurring is 0.4. Okay, the outcome then for A, okay, will be equal to 15 minus the mean. Okay, 12.6. Okay, we multiply by for asset B. Okay, the outcome then is 10.5. Okay, the mean return is 6.3. The outcome, okay, the chance it occurs is 0.3. Okay, the outcome then, okay, for A is 10 minus the mean, 2.6. We multiply by the deviation for asset B, which is 5 minus the mean, 6.3. Okay, that gives therefore what will be therefore the covariance. Okay, the sum of those deviation multiplied by probability give us therefore the covariance between A and B, which is how much? Okay, and we get 2.22. Get 2.22. Therefore, the covariance between A and B. Percentage squared. Okay, this is percentage squared. Okay. So what does it mean? Okay, it doesn't give us much information. All you know that is positive. Okay, but I mean therefore if A is increasing, then B is going to be increasing. If return for A are decreasing, the return for B will be decreasing. But it doesn't tell us much about it. Okay, that's why we say that it's worth enough to determine what referred to as the coefficient of correlation. So the coefficient of correlation between two assets. Okay, the coefficient of correlation that we call between A and B. This is given as covariance between A and B. We divide by the product of the standard deviation A and B. Okay, this is given us 2.22. We divide by standard deviation for A. Okay, we have done that. For A, we got 2.11. 2.11 multiplied by standard deviation for B, which is 1.05. 1.05. And get how much therefore with the covariance, the correlation coefficient between A and B. Okay, and we get 1. Okay, wow, and we get 1. Now, what does 1 imply? Okay, what does 1 imply? We say that if you're going to have, when I said generally, the main advantage of having or doing the coefficient or correlation is the main purpose is to assess, okay, how do the return of A and B behave, okay, towards each other, okay, and of course, to what extent does A influence, to what extent does return of A influence the return of B, okay, and of course, vice versa. Now here you got positive 1, okay, what does imply that there is perfect positive correlation. That implies therefore, if A increased by 10%, then B will increase by 10%. If B decreased by 3%, then A will be decreasing by 3%. Okay, that's what I mean by perfect correlation. Okay, now covariance didn't make sense. Okay, but now we're able to make sense out of the figures by the use of the coefficient of correlation between the two stock. Okay, by use of the coefficient of correlation. Okay, if it was negative, then if A increase, then of course B will be decreasing. Okay, so they move in opposite direction. Okay, that is what the coefficient of correlation do imply. Okay, I hope it's clear. It's very clear to all of you. Okay, that is the coefficient correlation between A and B. Okay. Okay, the next part, so you've been asked to get the return of the portfolio. Okay, in case we have portfolio here made of A and B, portfolio of A and B. Okay, don't forget the portfolio. We said there is an investment. Okay, or group of assets. Okay, that are viewed as if they are a single investment. Okay, so in this case, the investment we have here, the portfolio, is made of A and made of B. Okay, the investment that is made towards A is 60%. Okay, and the investment made towards B is 40%. Okay, we say the return of portfolio, okay, is given as return of the individual asset, weight of asset A, okay, multiplied by the return of asset A plus weight of asset B, we multiply by the return of asset B, okay. Asset A, weight of asset A, we told is equal to 60%. The return expected of A, we got 12.6. When we got 12.6%, okay, 12.6%. We did invest 40% towards B. The return we expect to receive from B is 6.3%, and that therefore given the return expected from the portfolio. Okay, 60% in A and say 40% in assets B. To give us how much? To be the return on the portfolio, therefore. And we get 10.08%, 10.08% to be the return of the portfolio. Okay, the return of the portfolio. That's how we get portfolio return. Okay, that's how we determine portfolio return. Okay, by determining how much do you invest in each of the stock. Okay, in each of the stock, multiply by the individual return, the return from the individual assets that do make that particular that do make that portfolio. Then part 5 is asking us to get the compute the risk of the portfolio. We determine the risk of the portfolio. Okay, so that's part 5. So let me introduce what we call portfolio risk. Okay, let me introduce portfolio risk. Risk of portfolio. You just said that the return of a portfolio is simply the weight of the asset. Okay, the sum of the weight of the asset multiplied by the return of that asset from the first asset we have all the way to the end asset that makes that portfolio. Okay, it's quite easy to get the return of portfolio, but that doesn't mean the same applies to the risk of the portfolio. Okay, the risk doesn't mean that the risk of portfolio is going to be the weight of the asset times the risk of the asset. No, that's not going to be the case. Okay, Why? Because there's game we call correlation. I think I just mentioned about the correlation. Okay, that there's game with interaction. Okay, there will be interaction of the return of the individual asset that makes a portfolio. Okay, so that means therefore, essentially, okay, we cannot just say that the risk of the portfolio is a sum of weighted average of the risk of the asset that make the portfolio. Okay, that's not the case because of the correlation between the return of the individual assets that make the portfolio. Okay, maybe you can just put that as a note. Okay, that the risk of portfolio, the risk of portfolio, okay, is not simply the weighted average. Is not simply the weighted average of the standard deviation of the individual assets that makes a portfolio, that make up the portfolio. Okay, so it's not simply a weighted average. Okay, why? Just answer why. Okay, because of the interaction, because of the asset return interaction, because of the assets return interactions. You can see here coefficient of correlation. Okay, as shown by the coefficient of correlation, which means therefore, if we don't have the coefficient of correlation, then simply the risk of the portfolio is going weighted average. If we have zero, okay, in case we have zero coefficient of correlation between the two assets, there is no interaction, in short, okay? We don't have asset interaction. Then in that case, therefore, the risk of the portfolio is simply the weighted average, okay? But if we do have some correlation, either positive or negative, whatever it is, okay, then therefore we cannot just do a simple weighted average, okay, risk of the individual assets that makes the portfolio, okay, that makes up the portfolio. But in case there's no interaction at all, zero intercorrelation between the return of the individual assets that make the portfolio, then the risk of the portfolio is simply weighted average of the risk of the assets that makes up that portfolio. Okay. Okay. Hope it's clear. Hope that's all clear. Okay. I want to go to my next page. Okay. So if you remember, we did say that the risk is simply the deviation. Okay, one of the best easier to mention risk is simply deviation. Okay, what's the deviation? What's the range? Okay, if you remember when we were discussing on the variance, okay, if you remember discussing the variance, we see that the variance, okay, is equal to sum of deviation. So return of asset A, say asset A. Mean return was at A, okay, squared, okay. This is simply a recall, okay. I think you've done this already, okay, from the first data set all the way to the nth data set, okay. If we are dealing with a portfolio, okay, in case a portfolio, don't forget we don't have asset A only, we have A and B, okay. If we are dealing with a portfolio, we have two assets, okay. So here, therefore, the variance of the portfolio, okay, will be equal to the return received from the portfolio minus the mean return received from the portfolio, okay, of course squared, okay, from the first outcome all the way to the nth outcome, okay. This is all clear, I hope, okay. We did say that the return, of the portfolio, okay, we could remember, okay, the return of the portfolio, okay, or even return from the portfolio, just return the portfolio is gained the weight. Assume that this portfolio is made of two assets, okay, A and B. Weight of asset A, return of asset A, plus weight of asset B, return of asset B. Okay, the return expected of the portfolio, okay, is weight of asset A. The mean return was at A, okay, plus weight was at B, mean return was at B. Okay, this all here, I presuppose. Okay, which means therefore we can just plug in this figure here. Okay, we have said that this is the return of the portfolio received. This is what was expected. What if we just plug in these figures now in our equation there? Okay, what do we get? Okay, we're going to get. Let me just proceed here. The risk of the portfolio will be equal to. Let me just for the time being, okay, drop this part of the equation. Okay, first outcome all the way to the outcome. Okay, let me just drop it for the first for the time being. Okay, therefore, if I drop it, okay, this is how I'll end up with, okay, my equation like, okay, return the portfolio minus the mean return of the portfolio squared. Okay, return of the portfolio. Okay, we have it here. Okay, so we have it here. Okay, therefore, it will be equal to weight of asset A, return of asset A, plus weight of asset B, return of asset B. Okay, this is the this is the first term to the equation. Okay, this is the first term to our equation here. Okay, then minus the second term to our equation. Okay, the mean return of the portfolio, we have it here. Here it is. Okay, so we just plug in. Okay, it will be equal to return of asset A, mean return of asset A, plus weight of asset B, the mean return of asset B. Okay, all squared. Okay, now all squared. We need to square it. Okay, so all squared. Okay, all squared. Okay, and that gives therefore the risk of the portfolio. Okay, the risk of portfolio. Hope it's all clear. If it's not clear, don't forget you can stop me anywhere along the way. Okay, let's proceed. We put the like term together. Okay, we can put the like term together. If we here we can put A and A together. Okay, you can see here we have A, here you have A, here you have B, and here you have B. I think we can put the like term together. Okay, so let's put like term together. Okay, this will be equal to weight of asset A. So I want to remove the brackets in short. Okay, weight of asset A, return of asset A. Okay, this is a minus. We can see maybe a minus weight of asset A, the mean return of asset A. This still remain a plus. Okay, plus. Okay, weight of asset B, return was at B. Now this is minus plus, this is minus. Okay, this is a plus. Let me just highlight it. This is a minus. This is a minus. Okay, and this is a plus. I think minus plus remain a minus. Okay, so minus return was at B, the mean return of asset B. Okay, all squared. Okay, I've just opened the brackets. Okay, so here we have asset A. Okay, so here we have asset A. Now this for asset A, this for asset B. Okay, what if now this here you have weight asset A, weight asset B, weight asset B, and weight asset B here. Okay, so I can go ahead and say my equation will be weight of asset A, return of asset A minus mean return of asset A. Hope it's clear. Okay, plus I want to ensure that once I open the brackets, there is going to be a minus. So what if I do a plus? Plus, let me just put a plus here. Okay, plus weight was at B. Okay, return was at B minus, yes, remain a minus, mean return of asset B. Okay, so simply what I've done here is I've put the weights outside of the bracket. Okay, outside of the bracket. Okay. Hope that's all clear. This don't get squared, remain as squared. if you remember, okay, I presuppose you have done this already, okay, we'll call the quadratic equation, we said as per the quadratic equation, okay, a plus b, okay, squared gives us how much? A plus b squared. What do you get? Don't forget, you need to remember your maths here. A plus b squared. What do you get?
Good.
Sorry, with this look or who?
Yeah.
Okay, look, I'll tell you a squared plus
Plus 2ab
plus 2ab
plus b squared.
plus b squared. Yes, thank you. I see that you didn't miss that part of class when you're doing the statistics. Yes, it's a squared plus 2ab plus b squared. Yes, it is. Okay. Now, if you check out the equation here, okay, what is a? What's the best term to use here? I'm trying to look for a term to use here. Anyway, here, if let's open the brackets here, we square the bracket here, okay? So here, that's where I'm referring to, okay? Which means therefore, we can have this as, assume that this part of our equation is A, and this part of our equation is B. You're just assuming, okay? The entire part of the equation is A, this entire part of the equation is B. What do we end up with? We can add up, okay? Don't forget, I just want to plug this A here, okay? So let me put them well. So as I'm assuming the first part is our A here. Sorry. I'm assuming that this first part here is our A, this part here is our A, and this second part here is our B. So we just open the brackets, okay? Therefore, we end up with, okay? Therefore, we should add up with, with A, are A, this squared, because it's A squared. This is the first part of the equation, A squared, okay? The return was at A, the main return was at A, log is squared. That's for the first part of the equation here. So we're done with the first part of the equation here. Plus 2ab, let me just put b squared. Let me go straight to the third part of the equation here, b squared, okay? Okay, plus b squared, this is our b, this is our b, okay? Therefore, weight b squared, return was at b, the main return was at b squared, okay? This is our third part here, plus 2ab, okay? 2a, this is our a here, okay? Weight a, return was at a, minus mean return was at a, multiplied by b, b is weight b, this is our b here, this is a b, weight b, return was at b, the mean return was at b. So this is 2, this is a squared plus b squared plus 2ab. Okay, now it's all clear to you. I've just tried to open I've tried to square the variables within the equation there. I'm just trying to square them. I'm trying to open the bracket more or less. Okay. Hope it's all clear. So far, so good. Okay. Okay, this is our, don't forget, this is our variance of the portfolio. Okay, this is the variance of the portfolio. From here, the variance of the portfolio. Okay. The variance of the portfolio. Okay. Okay, let's proceed. So here, therefore, we're going to end up with, okay, weight a squared. Now, what is component here? What is this? This component here, we can use a term for it. What's that? What is a minus mean of a squared? Of course, we have a term for it. You've done this before. You've just seen it right now. Yes, that's variance. Okay, thank you, Kami. That's variance. That's simply the variance of A. Okay, deviation squared is simply the variance. Okay, deviation squared is simply the variance. So this is the variance. This part is the variance of asset A. Okay, so this is the variance of asset A. Okay, let me just replace it by the variance. So the variance of A, the variance of A, the same plus weight of B squared, and now this therefore become therefore this part therefore become therefore the variance of B. Okay, therefore multiply by the variance of asset B. Okay, plus 2. Okay, we have 2 here. Weight A, weight A, weight B, return of A minus the mean return of A, return of B minus mean return of B. Now, what do we call this part? Now, this part now, use a different color to highlight it. This part now here, this part now, what do we call it? That last part there, what do you call it? And that's covariance. Thank you, Lisa. And that's covariance. Okay, covariance between A and B. That last part is a covariance between A and B. Therefore, you can see our equation, okay, will be like weight of asset A squared, variance of asset A plus weight of asset B squared, variance of asset B plus 2 weight of asset A, weight of asset B, covariance between A and B. And that's how we get the risk of the portfolio. And that's the variance of the portfolio. That's the equation we use when getting the variance of the portfolio. I hope it's clear. You don't have to remember the process, you have just come to get the equation, but you must remember the final equation. So this equation, you must remember it. You may not remember the final, okay, I love the process, okay, how we got the equation, but you must remember how do you get the variance of the portfolio. You must remember that final part, okay. Maybe you may forget the process, okay. However, don't forget how to get therefore the variance of the portfolio, okay. So you must remember that final equation. The variance of the portfolio is given us weight of asset A squared multiplied by the variance of asset A plus weight of asset B squared times the variance of asset B plus 2 times weight of asset A, weight of asset B, covariance between A and B. Clear? Question? Okay, I presuppose silence means you have understood or simply have accepted. Okay, silence means acceptance. Okay, that's what I presuppose you agree. Okay, and that's how therefore we do get therefore the risk of the portfolio. Okay, this case is a 2 asset portfolio, A and B. Okay, 2 asset portfolio, A and B. Now, what if actually, okay, maybe just to expound our equation, what if now we have 3 assets? Okay, we have the portfolio is made of 3 assets. We made of A, made of B, and made of C, for example. Okay, if we have 3 assets, okay, if we have 3 assets portfolio, don't forget for the return, it's simply weighted average. Okay, so simply for the return, I think we have done that already. Okay, it's simply weighted average. Okay, of the individual, the weighted average return of the individual assets that makes that particular portfolio. Okay, what of risk? Okay, what of risk? Don't forget for the risk, it is not weighted average. Okay, therefore the risk we are going to add just terms here. Okay, for now asset C, because now we are going to have both A and B, but also C on top. Okay, we are going to have C on top of it. Okay, so let's just add there for the term for asset C. Okay, the term for asset C. Okay. Okay, this was A. Okay, so in case you have 3 assets, therefore the portfolio risk, okay, variance of the portfolio will be equal to weight of asset A, I'm simply adding another term to the equation, to our equation here. Okay, weight of asset A squared, variance of asset A plus weight of asset B squared, variance of asset B. Don't forget now you have asset C. Okay, weight of asset C squared, variance of asset C plus 2 weight of asset A, weight of asset B, covariance between A and B. But don't forget now you have C. Okay, plus 2 weight of asset A. We can also assess the return of A and C. Don't forget. The covariance is only between 2. Co means 2. Okay, only between 2. Weight of asset A as a weight of asset B. Covariance between asset A and asset C. Plus, don't forget also this B and C. Okay, this B and C. Okay, plus 2 weight of asset B, weight of asset C. Covariance between, sorry, this is A and B. Covariance between B and C. And that's how therefore you're going to get therefore the risk of the portfolio. Okay, the risk of the portfolio. Okay, the risk of the portfolio. It's good that maybe, okay, I don't know how they're going to remember the formula, but I guess once you apply it once time, first time, second time, third time, you will remember the formula. Okay, so it was just what I've just done here. Okay, I've added just a term C. Okay, C was not in the equation here, and here it was not there. Okay, this was not there. So that's I've just tried to insert our equation here. Okay, when it comes to get therefore the return of 2 assets for 3 asset portfolio. Now let's go back and apply our formula because this is what is of more of importance for now. Okay, I have not seen your exam asking you to get the risk of 3 asset portfolio. Okay, but as you can see here, you have been asked to get the risk of 2 asset portfolio. Okay, so you may have to know this formula quite well. Okay, now part 5 of equation, part 5 of equation question. Okay, was asking us to get the risk of the portfolio in number 4. Okay, I'm referring to the question from the question bank. Okay, that is part 5, question 5, part C, part 5. Okay, we are meant to get the risk of the portfolio. Okay, the portfolio we had. Okay, this was the portfolio. Where is it? Yes, this was a portfolio we had. Okay, don't forget this is a portfolio. Okay, 60 in A and 40 in B. That's our portfolio. Okay. Therefore, we're meant to get the risk of the portfolio. Okay. So we simply have been asked to apply this formula now. Okay, you've been asked to apply this formula. Okay. So let's apply the formula. The risk or the variance of the portfolio, okay, is equal to weight of asset A was 0.4. So 0.4 squared. We multiply by the variance of asset A. The variance of asset A, I cannot remember. So let's check. The variance was at A from our previous workings. Variance was at A. Yes, we have it here. The variance was at A. Here it is. Variance was at B. Here do we have it. Okay, so we have 2 variants. We already done that already. Okay, so variance was at A. So variance was at A. Okay, times 4.44. Don't square, because it's already squared. This variance, the 4.444 is variance already, so don't attempt to square, more or less. Okay, plus weight of asset B, which was, no, asset A was 0.6. The weight, sorry, this is 0.6, not 0.4. The weight of asset A is 0.6. 0.4 is asset B. Okay, therefore weight of asset B 0.4. Okay, squared. We multiply by the variance. We have just obtained 1.1 from our calculation earlier. Plus, okay, I'm applying this formula. Okay, I'm applying that formula. Okay, 2 weight of asset A, okay, which is 0.6, weight of asset B 0.4 times the covariance between A and B. Covariance between A and B. You have done that already. So let me look for the figures. Covariance between A and B. Yes, here it is. Covariance between A and B. We have done it already here. Covariance between A and B, 2.22. Okay, so I just plug it in here in our final equation, times 2.22. And that therefore give for the variance, okay, of the portfolio, the variance of the portfolio. don't forget, I'll just try to plug in our workings, okay, in our final equation here. Okay, I'll just try to plug the figures in, and that gives us therefore the variance of the portfolio. And get how much to be the variance of the portfolio? Okay, and we get the variance of the portfolio to be equal to 2.84. Okay, so 2.8416 percent squared. Don't forget this variance. Okay, so we get the square root to get the standard deviation of the portfolio. We get the square root. Okay, so the standard deviation of the portfolio, which of course the conventional measure of risk. Okay, now you can see in this question, you haven't been told what measure to use. Okay, but conventionally we measure this by the use of standard deviation. So we get the square root of the variance. Okay, the 2.8416. You get how much? 1 point. And get 1.69, more or less 1.69. You get 1.69% to be the risk of the portfolio. 1.69%. Okay, I hope the process was quite clear. Okay, on how we do get the risk of the portfolio. Okay, on how we get the risk of the portfolio. Okay. In this case, it's only a 2-asset portfolio. It's only a 2-asset portfolio. Clear? Question? Okay, if there is no question, you can attempt another question. Your examiner had asked some time ago. Let me try to trace the question. Yes, here it is. Question. If you check on December 2014, okay. Yeah, Amolo, your hands up. Let me check out. Yes, Amolo. Yes, Amolo. Yes.
I got to derive the formula by expression.
Oh, Amolo, you're breaking up.
Okay.
I can't hear you. Amolo, I can't hear you quite clearly.
I'm asking.
Yes.
I'm asking.
Yes, Amolo.
In the first equation.
The first
in
equation.
Our derivation.
Okay, the first
what
equation.
Does the R and R bar stand for?
Oh,
yes.
This return. So here, I hope this is what you're talking about.
Where? Yes.
Then this is what you're talking about. These two R and R bar. Here.
Yes.
Okay.
Yes.
What does R? So here, R means the actual return you'll be receiving. Okay. Once you have that apostrophe there, or maybe have just a straight line on top of there, it means it's the return expected. Okay. So R means simply RA or RP simply mean therefore is the return we are going to actually be receiving. Then R with that bar there, it means is return what we are going to be. So R without the bar is what you're going to actualize. Okay, R with the B with the bar is what you're going to be expecting. Okay, so R minus R bar simply means it is a deviation. Okay, the return you're going to receive was what you are expecting to receive.
Okay.
It's clear.
Yes.
Okay.
Yes.
Okay.
Yes.
Okay, so sure enough. So as I was saying, there's a question here you examine at us, okay? That is from the December 2014 question 3C. December 2014 question 3C. Okay, December 2014 question 3C. Okay, so go through it, okay? And now I want you to go in, so we can do it in the next 5 minutes. A very short question. December 2014 question 3C. Can you see that question? December 2014. question 3 part C. Okay, so let me give you 5 minutes and I group you into groups of 3. Yes, and come up with something. December 2014 question 3 part C. Yes, let me break you up a bit so that you can